A lithium cell that looks acceptable at receiving can still become the weakest point in a finished pack. Once cells are welded, connected, insulated, and enclosed, correcting a poor match becomes slower, more expensive, and more disruptive. That is why capacity grading must function as a production release decision before assembly, not as a quick sorting exercise. The objective is not simply to select cells with the highest nominal capacity. It is to identify cells that can behave predictably together under a shared load path. Usable capacity, internal resistance, rest voltage, cycling behavior, and traceability all contribute to that decision. Capacity variation has direct pack-level consequences. In a series group, one lower capacity cell can restrict the practical discharge window because protection logic must respond to the weakest point. In parallel groups, poorly understood variation can produce uneven current sharing and make later troubleshooting more difficult. Pre-assembly grading gives production teams an opportunity to separate weak or mismatched cells while rework is still manageable. Voltage alone cannot establish a reliable match. Two cells may show similar open-circuit voltage while having different usable capacity, aging history, internal resistance, or self-discharge behavior. Voltage also changes with rest time, temperature, previous charge state, and measurement timing. It should therefore be treated as one evidence field within a broader grading process, rather than as the final release criterion. A defensible workflow begins with incoming inspection. Verify cell identification, batch information, physical condition, contamination, swelling, terminal condition, and storage status before electrical testing. This prevents test capacity from being spent on cells that already show quality or safety concerns, and it separates incoming defects from behavior introduced during testing. The next stage is controlled charge-discharge testing. The recipe should match the cell chemistry, voltage range, current range, and intended pack application. Charge limits, discharge cutoff conditions, current settings, rest periods, and temperature conditions must be defined and applied consistently. Each record should connect the cell identifier with its test channel, timestamp, test steps, measured capacity, voltage endpoints, and any interrupted or abnormal events. Internal resistance adds another important diagnostic view. It can reveal aging, connection weakness, or abnormal impedance that voltage may not expose. However, resistance readings are affected by the measurement method, temperature, contact quality, and fixture stability. Cells with similar capacity but noticeably different resistance should not automatically be treated as interchangeable. Rest voltage review is also valuable when the rest period is controlled. A measurement taken immediately after charge or discharge can reflect surface effects rather than stable cell behavior. Consistent rest timing across batches makes voltage comparisons more meaningful. Abnormal voltage drift after rest may indicate self-discharge, prior damage, or inconsistent incoming history. These measurements then become rule-based grouping criteria. A practical rule can combine a capacity band, resistance window, rest voltage range, and exception status. The correct tolerance depends on pack design and application. Higher power systems generally require tighter matching than lower-rate storage applications. Clear rules reduce operator discretion by defining when to group, retest, or hold a cell for engineering review. Exception review is a control point, not an administrative delay. High resistance, voltage drift, incomplete records, unstable fixture contact, interrupted test steps, and boundary-level capacity results should all be flagged. A short decision note preserves the reasoning for future troubleshooting and audit work. Final release should confirm that every cell completed the required sequence, falls within the approved grouping window, and has no unresolved exception. The released group should be linked to the pack build record, creating traceability from incoming cell through assembly. Equipment selection directly affects this process. Independent channel control, compatible fixtures, stable measurement, reliable current control, and usable data export are essential. The DKDT50W20 is a 20-channel case example for lithium cell charge-discharge testing and balance maintenance, with independent channel design and data functions identified for this type of workflow. Buyers should verify fixture fit, calibration practice, software export, and current settings against their own cell formats and production requirements. Before welding or enclosure work begins, confirm that the cells are electrically similar under controlled conditions, that the records are complete, and that every exception has been reviewed. That evidence is what turns cell grading into a reliable pack assembly release system.